Generative AI refers to artificial intelligence models capable of creating new content. These solution capabilities include text generation, image synthesis, and automated coding. Such systems are foundational in modern AI deployments, enabling businesses to automate complex tasks and improve operational efficiency. Planning effectively for generative AI solutions involves understanding the underlying technologies, the potential applications, and the challenges involved, including computational requirements, data management, and ethical considerations. Clearly defining business goals is pivotal when preparing generative AI solutions. The process entails identifying how generative AI can add value, improve processes, or create novel business opportunities. Objectives might include content automation, enhancing user interactions through chatbots, or creating media assets. Well-defined goals ensure proper alignment of technological capabilities with business outcomes, facilitating effective resource allocation and realistic timelines. AI readiness analysis focuses on evaluating an organization's current technological infrastructure and skill levels to successfully integrate generative AI. Elements assessed include computing resources, data storage capabilities, network infrastructure, and existing AI expertise. It is crucial to identify possible gaps in technology or knowledge, shaping the subsequent training programs, resource procurement strategies, and upgrade plans. Data management forms the bedrock of generative AI solutions. Generative models, such as GPT-based systems for text and diffusion models for images, depend heavily upon large, diverse, and high-quality datasets. As such, strategic data planning involves consideration regarding data sourcing, data labeling, data privacy regulations, and bias detection. Ensuring compliance with global regulations like GDPR and CCPA is also pivotal for sustainable and lawful AI operations. Planning resources for generative AI demands careful budgeting of financial costs, technology acquisitions, and human resources. Financial considerations encompass initial technology investments and ongoing operational expenses, including cloud-based services costs. Technological tools include GPUs, data servers, and software licenses. Importantly, skilled human resources, including AI specialists, data engineers, and compliance experts, play a critical role, and their allocation must align with the project's scale and complexity. Choosing the right generative AI models is critical. This includes deciding between language models like OpenAI's GPT series, diffusion-based image generation models, or specialized AI frameworks for specific tasks. The selection should be guided by the intricacies of project requirements, computing resources available, and the nature of the data at hand. Model performance metrics, such as accuracy, scalability, and resource consumption, must also influence the final selection. Implementing generative AI solutions requires robust technological infrastructure. Cloud solutions provided by platforms like Microsoft Azure offer scalable infrastructure, including GPU-optimized virtual machines, managed data pipelines, and specialized services like Azure OpenAI Service. Decision-making regarding on-premises versus cloud deployments hinges upon business scalability, costs, compliance, security, and required computation power. Azure-based deployments often shorten implementation time and enhance system scalability. Ethics form an integral aspect in planning generative AI solutions. Ethical challenges arise related to misinformation, bias propagation, privacy violations, and user manipulation risks. Planning for responsible AI solutions entails embedding fairness, accountability, transparency, and privacy into the project from inception. Leveraging frameworks like the Microsoft Responsible AI Guidelines ensures adherence to ethical practices and builds user trust. Planning robust security strategies and regulatory compliance is crucial in generative AI solutions. Security measures include data protection, secure coding practices, rigorous access control, cloud security, and handling vulnerabilities efficiently. Compliance planning involves adhering to data protection laws, such as GDPR, HIPAA, intellectual property regulations, and regional cybersecurity mandates. This ensures safeguarding sensitive information and minimizing legal risks. Proactive identification and mitigation of risks significantly influence generative AI project success. Common risks include technological failures, security breaches, data privacy violations, and ethical backlash. Risk management plans should consist of clear identification of risk factors, quantitative risk assessments, structured mitigation strategies, and contingency plans. Regular audits and adaptive strategies can effectively mitigate risks inherent in AI applications. Effective generation AI solution deployment often hinges on team preparedness. Training programs must address gaps identified during readiness assessments. Typically, training includes AI and machine learning concepts, hands-on experience with generative models, data handling skills, ethical considerations, and compliance practices. Continuous education ensures skill enhancement, enabling teams to manage evolving generative AI technologies efficiently. Deployment planning for generative AI solutions encompasses strategies for initial implementation, testing, validation, and scaling. A reliable deployment strategy should include detailed testing scenarios, performance benchmarks, and contingency approaches. Maintenance planning involves regular updates, performance monitoring, continuous optimization, and periodic resource reviews. Implementing structured deployment and maintenance strategies significantly enhances the reliability and long-term operational success of generative AI solutions.